So drive an equation for the pressure in the cylinder as a function of volume. So that's your cylinder. Your change in x multiplied by the area of your piston is your volume, right? So F of gas equals F of all external. So the amount of pressure the entire universe puts on your gas. It's a lot of pressure. So we know that F of gas, F equals pressure times area. That's for the gas. And the F of all external is pressure times the area. So the amount of force put on the outside of the piston, the spring part of the piston, plus the force of the spring. So that the amount of force the spring puts on your piston. So you have the whole world pushing on it, and you have the spring pushing on it on top, right? So there is some. And remember, it's an elastic material, so there is going to be some pressure, or rather some force. It's a very mechanical engineering question. So the P, the total pressure equals the external pressure time plus the Kx, so your volume, over area. Right? Because you take you're following the math. So you bring down your area. You know that volume equals minus Kx and Fa. Right? And that is effectively your start of your relationship. So the moving piston equals the volume change, and the change in volume equals A minus change in X. Right? That's your change in volume. Volume equals AX. And your volume is initial volume, so V without the subscript minus V1. Remember, these are just subscripts. These are just how you describe them. So you can change it. It can change to V0, Vi, V whatever, V Johnny for all you want. So the change in the movement in actual spring equals the initial volume minus the new volume V1 over the area. Right? That makes sense, right? The moving moment of that piston over that area. Right? Hence, your new expression becomes P equals P external plus negative Kx over A. And hence, since negative Kx, change in X, equals V minus V1 over area, your relationship becomes Px plus K V minus V1 over A2. Just going to give you 1 minute to think about it. Changing mode. Just note down that equation if you haven't fully got it, and I'll get you to work on it later and then questions. You're going to be using that last equation. So with reference to the original part A, write down the equation for the explicit pressures P1 and P2. So what happens in the initial pressure and the final pressure, because you're compressing, right?